Problem 4, page 101. The coordinates of an object moving in the xy plane vary with time according to the equations x and y. So the coordinates, I have x and y. For example, as you see here, we have x in function of time and y is in function of time. It means if we have here x and y, uh, x and y depend on the value of the time t. It means at initial time t, we can say at t1 we have x1, y1 at this position. At t2, at time t2, we have xy at this position. For each time we change the value of t, we will get a new value of position. The question is find or determine the components velocity and components of acceleration at time t equal to 0. Okay, components velocity, we have Vx and Vy. If you say components vector of V, so you have to calculate V vector and Vx vector and Vy vector. But just component, you need to calculate only Vx and Vy. The same for the acceleration, we have to calculate Ax and Ay at time t equal to 0. And okay, uh, to have more space, I will change the page. First of all, I write here x in function of time equal minus 5. M is just the unit, meter, the unit. Okay, minus 5 sine omega t and yt equal 4 minus 5 cosine omega t. So x and y. These are the components of the position vector xt I plus yt j. Now I want to calculate first of all Vx and Vy. You know Vx equal dx, the derivative of the x component equal dx over dt. Before calculating this, I want just to give you an example about the derivative. If, just an example, x equal, we can say cosine 5t, x prime equal dx over dt equal the derivative of cosine is minus sine 5t times 5. Okay, the same if you have y equal sine 5t, so y prime equal dy over dt equal the derivative of sine is cosine 5t times 5. Remember well how you can calculate the derivative of sine and cosine. Okay, let's continue. Vx equal dx over dt equal minus 5. Here we have a constant minus 5 omega cosine omega t. Okay, this is Vx. Vy equal the derivative of y component equal dy over dt equal this one is constant, so equal to 0. D the derivative of a constant equal to 0, so of 4 over dt equal to 0. Minus 5 minus omega sine omega t. Okay, equal minus times minus equal plus 5 omega sine omega t. This is the answer. Here we have the x component and here we have the y component. Now I want to calculate ax. Ax equal d vx over dt equal and ay equal d vy over dt. dvx, it's here, vx equal, okay, I can simplify here, minus 5 omega cosine omega t. We have minus 5 omega. The constant doesn't change. You put minus 5 omega. This value you see here, we have omega is constant. So minus 5 omega times minus omega sine omega t, the derivative of cosine omega t, equal plus minus times minus equal plus 5 omega square sine omega t. Ay, we use this one, ay equal 5 omega times the derivative of sine omega t equal omega cosine omega t equal omega cosine omega t equal 5 omega square cosine omega t. This one is, here we have ax and ay. Now I want to take a special case at t equal to 0. At t equal to 0, find all these components. We begin with Vx equal minus 5. So here at t equal to 0, okay, equal minus 5 omega cosine 0. We put here 0. Cosine 0 equal to 1. So equal minus 5 omega. This one, 5 omega sine 0 equal sine 0 equal to 0. So 5 omega. Ax equal 5 omega square sine 0 equal to 0. And ay sine omega square cosine 0, this one equal to 1, so equal 5 omega square. So this is the answer in the case of t equal to 0. Second, I ask you to calculate the position vector. The position vector, I mean, you have to calculate v vector. And the acceleration vector, so you have to calculate a vector. To calculate these values, you know that v vector equal vx I plus vy j. I put vx, and vy, so we have, or this one, vx minus 5 omega cosine omega t I plus j component. Vy equal 5 omega sine omega t. So this one, here we have Vx and here we have Vy. Now we want A. A vector equal Ax I direction plus Ay j direction. Ax is here. Be careful. I am calculating in function of t. He asked me to calculate if t positive. Okay, in function of t at t positive equal 5 omega square sine omega t, and ay equal 5 omega square cosine omega t. These are the components. Okay, if I ask you to calculate the magnitude of the position vector r, or the magnitude of v and a, so r equal x square plus y square, and v equal vx square plus vy square, and a equal ax square plus ay square. If I ask you, look, I give you all the options. If I ask you to calculate the direction of each one, okay, the angle of the position vector equal tangent minus 1 y component over x component. The angle of the velocity vector equal 10 minus 1 vy over vx. If I ask you to calculate the direction of the acceleration, theta of the acceleration equal 10 minus 1 a component over x component. That's all. Thank you.